Good morning, students. This is your Shabuni ma'am. So I'm very excited today to come in front of you all, but that's virtually. Would have been more happy if I can see you people live in the physical class, but as you know, the situation is not that, but hope to meet you all physically. Okay, so children, I have already started your trigonometric functions. I'm on Monday. I have provided you some PDF materials and a audio file also. I hope all of you have followed the one. Correct. So I'm going to continue from that part. What I will tell you today, I'm going to teach you today some portions of that particular material, and I would like to explain you from that material only. I have chosen a topic here, trigonometric functions, and I hope you have already seen such tables have been given to you. A table which explain you that how to find out the higher angles. Students, in class 10, we were all restricted to few angles, and we were all restricted to only first quadrant. That is, am I right? Now, we have started about the values of the angles in a certain table. I hope all of you remember that. That is 0 degree, 30 degree, 45, 60 and 90 degree. Now, as a broad spectrum, we cannot restrict ourselves in this specialized stream of mathematics. We are going to go higher and higher and higher, and we are going to revolve throughout this particular quadrant as I mentioned you. Fine. Now, this table is already been provided to you. Let's recall. I told you in that particular material that all the 6 trigonometric ratios are positive. In which quadrant? First quadrant. We did not worry about the sign in the first quadrant. That's why never worried about in class 10 about that. But now we are jumping across that 90 degree. This was the only limitations of ours in class 10. Now we are jumping across 90 degree. So from 90 degree, and we are in the second quadrant till we are in 180 degree. Then we are again moving from 180 degree to plus 90, that is 270 degree, and from 270 degree onwards we are again coming back to 360 degree. But is this the last process? Is this the last angle? Never. I have explained you that we are going round and round like this, and it can be attaining any angle as you wish. It can be 360 or 3600 or 3 lakh also. As per the values we can find out based on the known angles, we can find out their values. We have sine, cos, tan tables also. But what we are going to do in this class 11 syllabus? We are not going to take the help of the table. We will be finding the angles, the higher angles, with the trigonometric ratios with the help of the class 10 known angles. Am I clear? Okay. So for that, we have to use 2 basic rules. The first thing we have to remember is the one I have just now mentioned, and the second rule, that is any angle alpha. So what is this alpha? So you are given any angle. I have taken certain examples also, as you can see in this left hand part of the board. 330, 570, 11 pi by 6, blah blah blah. It can be any angle. Correct. So I am telling this type of certain example angles as any angle, and any angle can be written as a multiple of 90 degree with a plus minus theta. It is not compulsory that every time all the angles are multiples of 90. As you can see, we are moving in the multiples of 90. Correct. that is 0 to 90, then 90 into 2, 90 into 3, 90 into 4, and it will be moving on. But it's not compulsory that it will be always multiples of 90. It can be something more or something less than a multiple of 90, which is coming first into the mind. Fine. So first we have to remember that any angle like alpha can be expressed as 90 into n. What is n? N can be any value. As I said, 1, 2, 3, 4, whatever. Plus minus theta. Correct? And theta in this syllabus, we are taking help of the known angles only, whose value are well remembered, well learned by us. Correct? So these are the quick values we have taken it from class 10 level we have studied. So that's why I am writing these angles, which you will be studying more values in class 11. I am not taking them. So up to this I am taking, this is only what we know. Correct? Now see, remember, so children, remember, all the angles are positive here. All the trigonometric ratios are positive here. In the second quadrant, sine and the reciprocal of sine, that is cosec, is positive. And what about the rest four? They are negative. In the third quadrant, tan theta and cot theta is only taking a positive answer, and the rest is negative as usual. The last but not the least, that is the fourth quadrant. In the fourth quadrant, remember, only cos and its reciprocal, that is sec, is positive, and the rest four, say sine, tan, okay, cosec, that is negative. So as we remember, all sine, tan, cos, all sine, tan, cos. Okay, so if sine is remembered, we can go for a reciprocal also. We need not remember like separately. Fine. Now let's do a problem to get a more broader idea with that. Let us assume an angle alpha is the first example, that is sine 330, and I am here to find out the value. Sine 330 degree. What you will do, listen, you will be first writing this 330 as a multiple of 90 plus minus any theta type. That is, for example, one child can write 90 into 4, that is 360, minus 30 degree. Correct? One child can even say that, ma'am, I am not writing 90 into 4. I am restricting myself to 90 into 3, that is 270 plus 60 degree. So you can see one child is splitting the particular angle 330 degree as 90 into 4 minus 30 and 90 into 3 plus 60. So here is an important point I want to explain you. This n can be even number like this. This n can be a odd number like this. Correct? What to do at that moment? Now let's recall one thing. Class 10. 90 minus theta and theta. What were they? Yes, complementary angle relationships. I hope all of you remember it very nicely. We have done lots of problems based on that, isn't it? So, remember children, sine 90 minus theta is cos theta. Cos 90 minus theta is sine theta. So, what is the complementary pair? Sine with cos, tan with cot, sec with cosec, sine with cos or cos with sine. tan with cot or cot with, okay, and then sec cosec. And 90 minus theta, that means 90 into 1, 1, 1. 1 is a what? 1 is an odd number, correct? So, in that sense, please do remember, whenever, listen very carefully, whenever n is odd, I'm coming to the point. Whenever n is odd, the sign will convert itself to its complementary pair, that is cos 60. Sine will convert it to cos, cos will convert it to sine, tan will convert it to cot, or cot will convert it to tan, sec will convert it to cosec, or cosec will convert it to sec, when this n is odd. Got it? Converting stops when this is even. Yes, children. When n is even, sine remains sine, cos remains cos, tan remains tan, cosec remains cosec, sec remains sec. No changes. I've provided you a table also. Please do follow that. Everything is explained there in the writing, and this is the explanation. So let's recall once more. When n is odd, sine will convert it to, or the trigonometric ratio will convert it into its complementary pair. When n is even, all the trigonometric ratios are going to remain same as it is. First thing, first rule. Over. Second rule. What is the mother function here? Whom do we call a mother function? It's just, I'm calling it a mother function. Okay. This is the main function. This is the main question. See very carefully. Sine. Sine is the main trigonometric ratio here. What is the behavior of this sine in this particular angle? Now, how do I find where does it lie? Look, this is an important question. How do we know where it is lying? See, 330, visually only we can calculate and we can see it is in the fourth quadrant. But suppose we are not able to find out, it is something higher angle, say 740 or something, 800 and something, or 900 and something. So in that case, how I am going to take a help from this splitting? Correct, children? 19 to 4, one complete rotation, that is 90, 90, 90, 90 minus 90. Again, 90, 90, 90, 90, 19 to 4, again back to the fourth. Correct. Here, 90, 90, 90, 90, 90, 90 plus 60 degree. Understood? So, if it is okay with you, you can calculate in which quadrant it is, it's fine. Otherwise, say you are writing 720 plus something. Say the angle maybe your 720 degree, that means it's a second rotation. For 1440 degree, again one more rotation, 2880 degree, one more rotation, and I hope you can understand that. Fine. So if I will say, if the particular angle is say 2900, and you can easily find out where it is. Definitely it is in the first quadrant, and you can calculate well. If the entire idea of the rotation and the angles comes into your mind, it's all depends on the practice. It's all depends on the practice, children. So please, let's recall one more thing, the two rules, okay, that is, first, when we get the particular angle, we will split it. If it is 19 to 4, then we will be calculating it as even one, and sine will remain sine, and for 19 to odd, it will be turning to the complementary angle. Now the second thing, this is in the fourth quadrant. Fourth quadrant, sine behaves. The behavior of sine. The fourth quadrant, sine is negative. So I'm going to write see, sine is sine, and the minus sign comes because in the fourth quadrant, sine, the sign of sine is negative. Correct? Now, here somebody can split it in this way. So the fellow will write it as, because it is odd, cos 60. Okay? With a minus sign, because again it is in the fourth quadrant. So what I want to make you people clear, some student make a mistake. They see the answer angle, that is cos, and they think, okay, cos is positive in the fourth quadrant. Please never do that mistake. Mind it. See the main angle, the mother function, the mother ratio here. Okay? See how it behaves in the particular quadrant. Okay, students? So the first is over. Then quickly comes to cos 570 degree. Now calculating mine 570. How can we convert? How can we split 570? Tell me. How can it be split it? Okay. So say one can write. See, the splitting depends on you also. So I'm writing here, say 19 to 6 plus 30. You can go with anything else. Like, say anybody can come down to 630 minus 60 also. Fine. That depends on you. I need the answer, that should be, and I need the process, that should be correct. Fine. Now see. So since it is an even multiple, so cos will remain cos as the first rule says. No conversion of cos to sine because it is 19 to 6. Correct. Cos 30 comes down. Important question. What is the quadrant it is falling? It is landing to. In which quadrant cos is landing to? You say, when watch which quadrant. If by only looking you can say that, ma'am, it is in this quadrant, that's fine. That's very much fine. Otherwise, you see, 90 into 4 gives you a complete rotation. Then again a 90, again a 90. See, how many times? 6. How many times? 6 times. So one complete rotation, 90 into 4. Then this plus 30. So which one? Third. Okay. That is 1, 2, 3, 4, 5, 6 plus 30. 1, 2, 3, 4, 5, 6 plus 30. Okay. So by more practice, you need not to calculate 1, 2, 3, 4. You will be able to do it because you will have a very great idea of calculating the one. So what about in third quadrant? Okay, this is again negative because the only two trigonometric ratios which are positive there is tan and cot. Correct, children? So it is minus root 3 by 2. It is minus root 3 by 2. Is it okay? See, the third problem I have written in the radian format. Tan 11 pi by 6. I hope you went across the material where I have mentioned you very well how important is this conversion of degrees to radian. And when the problem is in the radian, you please, I have seen students converting the radians into degree. Please don't do that. Try to solve it here with the radians only, and you will be, I think, solving the same as I'm guiding you. Fine. So it's 11 pi by 6. It is 11 pi by 6. Can I split it like this? 3 children, very carefully for you. Satisfy yourself with explanation. 2 pi minus pi by 6. Yes. So 12 minus pi. I hope it is clear. Okay. Shall we proceed then? Fine. 2 pi. Okay. 2 pi. That means pi means 180 degree. Pi means 180 degree. So 2 pi means 360. 2 pi means 360. Fine. So 2 pi, one complete rotation. Then less than that. Where it is landing? Where the star is landing? Yes, it is landing in the 4th quadrant. So again, children, it's getting a minus sign. Fine. So minus tan pi by 6. So minus tan pi by 6. And what about why it is tan to tan? Why not the tan converted to cot? I'm sure you got the point. What is that? Because, yes, because it is even multiple. Because it is even multiple. Fine. So, now I know this is a known angle. What is pi by 6? I have given that entire circle with different values of conversion of radians to degree. Please do follow that, and please keep it in mind, the entire table, that what is like pi, what is pi by 2, what is pi by 6, what is 3 pi by 2, what is 2 pi by 3, what is 5 pi by 6, everything, pi by 12, pi by 18, everything you have to keep it in mind. Okay, so what is the value in that case then? I'm going to write down the value, the answer. Please have a look on this. Okay, so moving to the last question. Here, this is very important when I'm taking some more angles for you all together, and the question is to evaluate. I'm rewriting the problem for you. See, what is the problem? All the 4 values are there and I have to solve it. Correct. 8 pi by 3. What is it? 8 pi by 3. Let's convert it to the best angle, closest one. I know it. Can I write down this one? Look very carefully, huh? Observation is required. Please do focus here. 9 pi minus pi by 3. See, it is giving 8 pi by 3 only. Isn't it? Into 23 pi by 6 can be written 6 4s are 24. 6 4s are 24 minus pi, that is 23 pi by 6. Then cos 13 pi by 3. Cos 13 pi by 3. You can write it as 3 4s are 12. 12 plus 1 is 13. 12 plus 1 is 13. So, see what I am writing. 4 pi plus pi by 3. It is also giving the same thing. 35 pi by 6. 6 6 are 36. So I hope you're getting my point. How I'm converting. I'm always converting into the known values I know. I'm not jumping here and there. Okay, because I do have that handful of known values only. Fine. What we have started in class 10. Now I hope you can convert it well. 3 pi minus pi by 3, this is a even multiple, means yes, definitely you will say 3 is not even number, ma'am, but yes, definitely 180, that means 19 to 2, so 2 3s are 6, so this is also, you calculate by yourself, 19 to 6 it will be coming, correct. So this sine will remain sine only, cos will be also cos, and cos is cos and sine is sine. So I did not to think about the first part, that is in which forms they are going to change. Now sine 3 pi by 3. So I can write it as sine pi by 3. I can write it as sine pi by 3. Now important question, 3 pi minus pi by 3. So in which quadrant it is? So 3 pi, that means 540. Okay, 540 minus some angle here, that is 60 degree. Okay, so in this case, I need not to calculate, convert it into degree. What I am going to do, please see very carefully. 3 pi, this is 1 pi, this is 2 pi, this is 3 pi, see, this is 1 pi, this is 2 pi, this is 3 pi, back, 3 pi minus, so 3 pi, 1 pi, 2 pi, 3 pi, am I exceeding? No, I am getting back. So I am dropping to second quadrant. So I am dropping to second quadrant. Second quadrant sine is positive. So this is how you are going to recall in mind. Correct, children? Now 4 pi. 4 pi means 2 complete rotations. And getting back to, oh my god, it is dropping back to fourth quadrant. So happy fellow to get a positive sign. Fine. So cos pi by 6. Fine. Cos 4 pi plus pi by 3. Not a happy. Yes, it is again a happy one. So I am going to the all positive one quadrant. That is the first quadrant. It is again cos pi by 3. The last but not the least, 6 pi. So 6 pi. This is 2 complete rotations. Then another, see, 6 pi. 6 pi means how many complete rotations? 3. Why? 2 pi, 2 pi, 2 pi, 2 pi minus pi by 6. Where? Fourth quadrant. Which quadrant? Fourth quadrant. Getting a negative, which one am I doing? Yes, getting a negative sign. See, getting a negative sign because it is sine. Because it is sine. Look very carefully. 6 pi, but minus pi by 6. 6 pi, but minus pi by 6. So I'm landing to which quadrant? Fourth quadrant. Fourth quadrant means what? Fourth quadrant means a negative sign for a negative for sine, a negative sign for sine. So it is going to give me, but with a negative sign, but with a negative sign. Now quickly I'm going to write down these values. So see, pi by 3, that is 60 degree. Pi by 3 means sine 60 degree. Pi by 6 means cos 30 degree. But cos 30 degree is again this minus sign comes here. Cos pi by 3. Again I am saying the same thing. That is 60 degree half. And this is another half. So what am I getting the value as? So this is root 3 into root 3. This is 3 by 4 minus 1 by 4. So this is half. Hence, after calculating. So few problems I have solved, okay, in front of you, and I hope you will be able to follow this. The next portion I will be going after this particular thing is the compound angles. We will be studying more in the next material and the video class. So that's all for today. Please children, do practice well, and please do complete more and more problems for this. Okay, so goodbye for today. Have a good day.